Hello, today's topic relation between linear and angular acceleration. So, in circular motion or rotational motion, we have to correlate these two terms. So, we know that linear acceleration A is equal to delta V upon delta T because it is rate of change of velocity. But to be more precise or to be more accurate, we replace it with the differential sign. So it is dv by dt, differentiation of velocity with respect to t. And in the same way, angular acceleration alpha equal to rate of change of angular velocity. So it is alpha equal to d omega by dt. We also know that linear velocity and angular velocity are also correlated with each other, v equal to omega r. Keep this habit of writing omega r and not r omega. If you study its vector form, then cross product is non-commutative, so omega r and r omega are not same. So that is why this time we haven't written it in cross product form. So proceeding further, so it is dv by dt, that's we have differentiated it. And if it is performing a circular motion or in rotational motion we are considering a single particle, then this r is a radius, simply radius, so it is considered as a constant, and here dv by dt is an acceleration. So which type of acceleration it is? So if this is that particle of a rigid body and which is rotating, or a single particle which is performing circular motion, then this is its linear velocity, which is tangential in nature, and along this axis it will be its angular velocity. So it is tangential velocity, and hence the acceleration will be tangential. So if we draw it in 2D plane, so here it is, this is that tangential velocity, and if this r represent its radius of its circular path, then the point coming out of the plane, out toward you from the screen, is omega, direction of omega. Alright, so now this dv by dt is not simply an acceleration, it is tangential acceleration. For circular motion there is another acceleration also, that is centripetal acceleration. We will discuss about it in some other video, but this time I want to tell you that angular acceleration is related with tangential acceleration. So that is why tangential acceleration is equal to r alpha, but keeping that thing in mind, it should be written as r alpha, keeping that cross product in mind when we